All right. So a lot of folks understand confidence intervals. We understand that we get it for the mean differences and we get it for the Cohen's d. And then I was like, well, why don't I just show them how to get it for every p-value that they ever calculate for a t-test? I'll show you how to do it for f as well. So essentially, we have our upper limit of our mean difference, our lower limit of our mean difference, our degrees of freedom from SPSS, and our standard error from SPSS. If you just take your numbers in, your upper limit and your lower limit of your mean difference, which you do get from SPSS and PSPP, put those in there, put your degrees of freedom in there, and put your standard error there, it will tell you your 95% confidence interval of your p-value. So I am 95% confident that my true p-value lies somewhere between 0.0001 and 0.16. Right? I want to show you this because we think p-values are infallible, but no, they're just a statistic, right? I took my lower limit and said, well, what if my mean difference was the lower limit? What would my p-value be? Well, in that case, my upper limit, right? In that case, my p-value would be tiny. My lower limit mean difference, my p-value would be massively large. I think this is important to recognize. We can not only interpret one p-value, right? That is sad. And so I just want you to see that for every test we've run, we can put in our upper limit of the mean difference, whether it's between, the known population mean or between two sample means, put in our lower limit, degrees of freedom from SPSS for the test. We directly take that off SPSS, standard error that was used in calculating the p-value from SPSS. And then I've just created a formula in here, if you want to look at it, t-distribution for, what's it doing here? So it's taking A2 divided by D2. So that is getting your t-score. And then it's saying degrees of freedom two-tailed. So C2 is your degrees of freedom, and that's just saying two-tailed test. What would your p-value be? And then you can imagine that this one's doing the same thing, but on the lower limit. Stop viewing p-value as special.